Hey guys, it's Ben, and today I'm going to be walking through the Magic HackTheBox challenge. This is a medium rated Linux box and it was quite interesting, so yeah, let's get on with it. I'm going to first copy this IP address, and I've got a folder set up already. And we can start off with an nmap scan to enumerate different ports, different services, look for different routes to attack basically. So I'm going to start off with nmap, put the IP there. I want to scan all ports, I want to get a full coverage, so TACP. I want to enumerate the software and the services and the versions of the services which are running the ports, opening the ports. So I'm going to do TAC-SV, TAC-SC for the default NSE scripts, TAC-N to not do a reverse DNS resolution, and TAC-PN. These last two just speed it up a little bit. TAC-O, and then I'm going to TAC-T4 actually, for a bit more of a speedy output. It will run the scan a bit more faster than the default speed, and then TAC-O for full thorough, just to output it to a file so I can reference it in the future. I have already run this command, so let's go through it now. We can cat full thorough, and there we go. We've got this we've got the command here, the output of the nmap scan, and we can see there are two ports open, which is quite nice. We know sort of where we're going to be attacking from, and that's most likely going to be the HTTP service. On these sort of challenges, it's very rare, if at all, that you would gain initial access by attacking SSH. I personally haven't seen it, and usually, yeah, web apps have a lot more different attack vectors you can use for initial access. We can see an Apache web server is in use. We do get the version there as well, and then we can see the title of the web page when you visit it is Magic Portfolio. We can obviously see this is running on Linux box, but we knew that already. I have added this IP to our host file, so if I go sudo vi etc hosts, we can see, yeah, down here we've got the IP and the host name there, so I do not need to reference the IP anymore. I can just reference magic.hackthebox and it will automatically resolve to the IP address of the box. I'm going to do some, well, first of all we can just check the website out, right? We can go to magic.hackthebox, and we can see there are what looks to be loads of different photos, and we can sort of scroll through them, and then if you look in the bottom right hand corner, we've got links to what looks like social media. Hovering over these, we can see in the bottom left hand corner they do not go to any link at all, so they're useless basically. And then in the bottom left hand corner we can see please log in to upload images, and we can see, look, maybe there's some image upload feature. So we'll open that on a new tab, and we can see we've got this login portal here. We can have a look at the web technologies in use. I'm using Wappalizer. This is an extension you can add to Firefox, and it will just enumerate the web technologies which are in use by a particular website. In this case, we can see, yeah, Apache web server. We figured that out before. It's running on Ubuntu, and it is also using PHP as the back-end programming language. So far, this is sort of just looking at this website alone. We could obviously look at the source code. This login page looks to be the only route to, was the only thing we can really look at to begin with. However, there may be other stuff which is hidden to us, so I'm going to do some fuzzing. I'm going to fuzz directories, virtual hosts, and files on the web server to see if there's anything else which isn't, we can't see it first sight. So I'm going to go into the web directory. I'm going to make directory fuzzing, cd into fuzzing, and I'm going to use fuff to do this. The TAC-U, and then we'll specify the website, the URL which we're going to be fuzzing. And at first I'm just going to fuzz this top level directory, so I'm going to use the like the placeholder word fuzz here to specify what we're actually going to be fuzzing. The word list I'm going to use is from the seclist word list, and that's word list, seclist, discovery, web content, raft, medium, files, dot text, and we're going to filter by the HTTP response 404 to begin with. So filter code 404, and then we'll tee this to fuzz files.log, and this will basically tell us we're going to go through this word list of all these different files, and it's going to send a request to the website, and if the response code isn't 404, it's going to display it. So we're basically finding files which don't give a response code of 404. We'll do this, and we see we're getting quite a lot of 403s. We do see a 200 there, so that is obviously a legitimate page, but this 403 is permission denied, so we can add this to our filter as well. So filter code 403 as well, and then we should be able to get a better output of all the files which are available at this top level directory. I'm also going to do the same thing for directories, just to see if there's any directories which may be of interest. I'm going to output this to fuzz.log for fuzz directories, and I'm going to use raft medium directories as my word list, and I will let that run as well. We can see two pop up straight away, images and assets, and then from the files we see we have the login, logout, upload, and index.php. Two of these have a 302, so they're going to redirect us to somewhere. Index.php is just the page we went to at the beginning, and the login.php is the one we've already looked at, because this is login.php. So what we can do, we can check out the upload.php, and we can see this redirects us. We saw the 302, it redirects us straight to login.php, and then the logout will probably be logging out. I don't know where this will redirect us to, maybe index.php, the main page. So we've sort of confirmed by looking at the at least the files that login.php is most likely going to be the endpoint we want to attack. So we can start off with some default credentials. Just try out some, maybe like admin, and we see we get this like JavaScript alert pop-up thing if you and it just says wrong username or password. We could try maybe admin password, and we get that again. So there are quite a few different things to try with bypassing authentication or looking at a login portal. You may want to go to HackTricks. They've probably got a good bypass login. They've probably got a good write-up on it, login bypass, and there will be a lot of different possible attack vectors you can take for this login page. One I know to some extent is SQL injection, so you may want to test out what happens if I put like a quote here, to see if it gives some error, and then we'll just put a random password. It's not necessary. We'll just do this, and we see this time we don't get that pop-up login box saying saying wrong username or password. So we know something's going on in the back end, that it doesn't like that quote which we've included. Maybe it's disrupting the logic of the SQL query, and it's not causing it to give that error. So that really interested me. As soon as I saw that, I was like, this must be SQL injection. So what you may want to do is get open Burp Suite, and I'm going to do that and just have a play around, try some of your like the bypasses, the login bypasses, authentication bypasses with SQL injection. I'm going to send another request, and one thing I wanted to notice, you can't, I'm pressing the space bar now, but you can't use the space bar in here, which is a bit annoying, but in Burp Suite we can manually choose to bypass that. So we'll just send this request, and we can see the request is here. I can send that to the repeater, and we can just try a normal request, and we can see, just like this, we see that JavaScript alert which popped up wrong username or password, and then if we put the quote in there like we did before, we can see that doesn't appear. So there's definitely something going on with SQL injection. What you may want to do is just try or 1 equals 1. This is something I do just as a quick check. It's not usually recommended, but sometimes it works. Doesn't seem to do anything. We get the same response as earlier. So in this case, I just decided to get SQL map out. It's a tool for automating the process of SQL injection and checking it. It's a good tool, so let's just use this. We'll go into the the exploits directory, cd exploits, and I'm just going to say login request.txt, and then I'm just going to put the HTTP request we have here. So we can see there's the post to login.php. I'm saving this HTTP request in a text file, and a good thing of SQL Map, you can just pass this HTTP request straight in and it will do it all for you. It saves you using all your flags and everything like that. I can just go SQL Map login request.text, and then you can adjust the risk. We can also have a look at SQL Map TACH, and it will give you a bit of a explanation of the different switches which are in use, and you can use. In this case, we can see there is a risk 1 somewhere, level or risk. The default is 1. If this was a real environment, yeah, I would, or a bug bounty, I may just go for 1. This is a box, which is obviously, it doesn't really mind if we break it, so I'm just going to use the highest risk, as we're more likely to get better results out of that. So I'm just going to do the same thing here, SQL Map request login request.txt, and then the risk I'm going to set to 3. And then we can see what results we find out of this. And the thing is, I have run this before, so it's giving me the output of what I've previously run. It's cached it and it can realise I've run this command before. If you ran this for the first time, what you may see is it would go through a lot of processes, and it would eventually find out more details, like the backend database is MySQL, and it would find out the different payloads you can use and the type of SQL injection you can use to exploit this. We do have some more details here now. We know the backend database is MySQL, so we can go dbms, and I'll get the switches up. SQL Map TACH. So we can choose the, I'm looking on this side, we can set the dbms to be here. The dbms is to be MySQL, and then what we've identified, there's this SQL injection, which is a blind SQL injection. There's both time-based and Boolean-based. What do we want to do? So I really want to dump this database. I want to get all the information out of the database. So I can use the flag all, or perhaps dump all the database table entries. So let's just try this. Dump all, and we'll see what we find out of this. It gives us an option to follow to this upload.php. I'm going to do this. Do I want to resend the original post data to a new location? I can say yes on this. I can't remember if that's exactly right. And then we can see after doing this, it starts retrieving information. So it's looking at the information schema here. And it will go one by one, dumping the database, the whole entire database. So this can take a little bit of time, because this is like a blind SQL injection. It does it like brute forcing by sending multiple queries. I don't know if it's doing time or Boolean based, it may say somewhere, but it takes time. It has to basically enumerate the database character by character. So I may skip ahead until it fully enumerates the database. We will see. It may take a little while. One thing I've realised I've done, which probably is going to make it take longer than it needs to be, is I've done dump all. I could probably just do dump, and that will just get the database which is in use instead of the whole dbms. So I'm going to do that. I'm going to change this to dump, and then hopefully this will take. I mean, we've got the output there, right? This is from my previously run command. We can see it works in a similar way of it does it character by character, and then eventually it is able to recover the username and password by using that time-based Boolean injection. So we do have these credentials. Admin is the username, and then we've got this password here. I am just going to say vi, I'm just going to echo, and I'm going to admin, and then I'll get the password here, and then I'm just going to say creds.txt, just so I can store them. We can cut out creds, and we've got the creds in a text file here. So I am going to log in with these creds now. I'm going to log in with these creds. We can turn off the Burp Suite proxy. The username is admin, and the password I've got saved to my clipboard. I can log in with this, and then hopefully this works. We'll see. Does seem to be going a bit slow. Can I still access magic.hackthebox login.php? We can. I'll try again. Maybe it just being slow, and it does. We're able to log in, and then we've got the option to select an image to upload. So at this point, I was sort of guessing we have to maybe upload a payload or an image which contains a payload to get some sort of web shell or reverse shell, as that seems to be like the only route. We've done all our fuzzing of our files, and this seems to be what we have to do. So we can try just uploading not an image but like a PHP file or a text file. So let's just do that, right? Let's make a directory upload test, and we'll cd to upload test. I'm just going to make a test file, test1 dot, let's just say txt, and I'm just going to say hello world, and we'll see what this does when we try to upload this. When I was doing this challenge, it's really a lot of trial and error, just playing around, and then you sort of discover what's going on. This was called the magic, and I'm doing a magic walkthrough, exploits, and then we had this upload test, and it was test1.txt. So we can upload this, and we do see only JPEGs and PNG files are allowed. So maybe it's figuring that out by the file extension. So what about if we try to change the file extension? Let's just move test1 to test1.png. What does this do? And we'll try upload this, and it gives me the message, what are you trying to do here? So it clearly is detecting it's not an image. So let's have a look actually at the request which is being sent to the web server when we try upload this. So I'm going to get open my Burp Suite, and I'm going to upload this test1 image again, and we'll see what happens. So we'll upload it. And we do see it's got the file name test1.php, and the content type is also set to a PNG. So, and it's still detecting something is going on. So perhaps it's using like the magic bytes, or it's checking for certain strings which always exist in a PHP file, and it's doing it like that. So that clearly doesn't work. What we can do is just test it out with a real PHP file, and then see if we can. What I'm trying to do is sort of figure out in the backend PHP, how is it detecting whether a file is a PNG file and whether it's not just a malicious payload. Once we figure out how that sort of logic works, we can perhaps bypass it. So let's get an actual PNG file. I'm just going to download one from the internet. I've still got my Burp Suite proxy on, so I'll turn off that. There's this dice here. I'm going to download this, save image as. And then I want to go in magic walkthrough exploits, and then I'm going to call this, it looks like this is actually a JPEG perhaps, test1.jpg. I'm just going to save it as that. It shouldn't make too big of a deal. What I'm going to do is I am just going to go head on test1.jpg, and we can see yeah, it's got the JPEG header. I believe if this was a PNG, we would see a PNG at the top. I don't think this should cause too many issues, but we should be able to upload this. This looks like a legit image, right? What happens if we upload this image? So test1 JPEG, we'll upload this, and it says test1 JPEG has been uploaded. We could perhaps, if we recall, in our directory fuzzing, there was an images directory, so maybe it's uploaded there. Let's just have a look. Images, test1 test1.jpg, and this is what I did, and we got the 404 not found error. And then I remembered, if I just go back on this, resend, I remembered at the beginning there was this page with loads of images. We know our image that we uploaded looks like dice, so let's just check out, is there a dice which has been uploaded, a picture of dice? And there is, it's here. So we can click on this, and then what we could do is just inspect element, figure out what's the actual file path to this, so we know where it's actually uploaded to. You can hover over it with this, and then it will tell you it's uploaded to images, uploads test1.jpg, so we should be able to go here and just get the raw image file, like we did. Nice. So, let's try upload this again, but this time I'm going to intercept the request, and then I'm going to play around with it and see what's going on. So let's upload this again. We've got the request here. This worked before, so I'm going to send this to the repeater. Now I want to find out what if I change this to like a PHP, because we know it only accepts the file extensions. What happens now when I try to do this? We can see, sorry, only JPEG PNG files are allowed. So we know for sure it's testing the file, the end file extension to see if it contains a JPEG on the end. So what about if we do something like this? JPEG, php.jpg, or like PNG, I don't think it really matters. If we try this, we know it's going to check the PNG. If we upload this, it does say test1.php.png has been uploaded. So if we go to here, test1.php.png, and we can see this time when we do it, it's treating it as a text file instead of an actual image file. So my idea here was, if I included in this file here a PHP web shell, so let's just try this. If we just include, because it's treating it as a text file, if there's the PHP like tags in there, it will treat that hopefully as PHP executable code. So we could include a web shell system, and then we're going to take a get request, and we'll say that get request is called command. We'll take that and we'll just execute that. The system command is basically, it executes system commands like any like shell commands like id, who am I, etc. And then the this get part here will basically take the get request with the get parameter command, and then it will pass that into system and execute that. So if we change this test2.png like so, and we send this request again, it says it's been uploaded, and then if we visit this again, test2, we'll see test2.png. We can't see that PHP tag which we uploaded in the raw text, which very likely means it's being executed on the back end. So what I do want to do is I just want to do this in Burp Suite, as I will show you why. Let's just make a get request to here. We should be able to do the same exact thing as we did in the browser. Get request like so. So we're making get request to that image, and I often get this issue. I cannot press on this whole entire left hand side of my screen, so I just need to do something real quick to fix this. I think I can go drag and drop, no, VBox, will this get it? These ones here, I just have to kill these processes and it seems to work after I do this. I've got no idea why this happens. 159 and 150. And now I can press on this left hand side of my screen. For some reason in Burp Suite sometimes I get that pop up, and then the whole entire left half of my screen doesn't work, but it does work now. We fixed it. Oh, and it's happened again. Oh no, it hasn't. So I can send this request and we get a 404 not found error. So if I go here, it looks like it's been deleted. That does happen sometimes, but we've got this other request here for this test2png, so we can upload it again, and it uploads. If we go back to here, we can send this request, and we do get the request there. We get the response. If we keep an eye on the content length of the response, and now we pass this command parameter, so we'll command like so, and then we'll just use a command like who am I. If we see the content length change, that means some text has been added to the response, which likely means the command execution has been successful. So we do this, and we can see it's gone up. If we go down, we can see dub data. So we could also do something like ID, and we see basically what I'm trying to say. We've got command execution. If we scroll down, hopefully we should see the response of the ID command. There we go, dub data. So that's working. We should, like this is a web shell at the moment, we should be able to upgrade this to a fully functional reverse shell. So I'm going to get a listener going, and then I'm just going to go to revshells.com, and I still have my burp suite on. Revshells.com. I'm just going to take this one here, which is set up for my IP. I'm going to go bin bash, and then the command I'm going to pass is this. We've got spaces in this which it won't like, so I'm going to do Control U to URL encode that. We can see we've got the listener on port 44, and that is my VPN IP right there, 10.10.16.4. So we can send this request, and we can see we don't get a response, which is good. What we're looking for is because it's currently processing. If we go back to our reverse shell listener, we can see we have successfully caught a reverse shell. At the moment, this isn't a fully functional reverse shell. It's not a TTY shell. We can upgrade that to a TTY shell with the PTY Python module. First of all, I want to identify what version of Python is installed, so I can use the which command, and we can see Python 3 is the binary which exists on this. Sometimes it may be Python, but when we run which Python, we get no response. Python 3 is the one which is in use here. So we can import pty, pty.spawn, bin bash. We want to spawn a bin bash tty shell, and that looks all good. If I want to clear the screen, we can see the term environment variable isn't set, so we can just export that term equals xterm. Now we can clear the screen. We've got a functional reverse shell, right? I'm going to go to the top level directory, and then I'm going to go into home. We can see there's a user called Thesis. If you recall in our, let's just do it over here. If we cd into HackTheBox magic walkthrough, that's not liking it. I'm just going to go back. It's easier, isn't it? There's this user called Thesis. We can just we can cd into that directory. We can see there's a user flag there. We can try cat that out. We get permission denied. We can see it's owned by Thesis, and it's got the right bit set. That means we can't open it. These credentials do contain Thesis was king, so perhaps that is the password. We could give that a go. We could just copy this here. We could go su thesis to change our user to him. Try these credentials, and we can see we can successfully change our user to Thesis, which is good, right? What I usually do when I want to privilege escalate, I do some basic checks before to see if there's any quick, easy wins. One of those checks is sudo tackl. A user can be configured to run certain binaries or certain commands as root without the need for a password or with the need for a password. This is usually a quick, easy win. If this has been configured, we can enter the password again, and we can see this user may not run sudo on magic, the host name here, on the host. So in this case, we haven't been configured to do that. That is not a possible privilege escalation route. Another thing I usually check is if there's any SUID binaries. So these are set user ID binaries. These basically allow the user to run with the permissions of the owner of the file. So if the owner of the file is root, when I run it, I will run with the permissions of root. So let's just go find, and then I'm going to use // for find files in the top level directory downwards. I want to search the whole entire machine. Tack type F, because I'm looking for files and not directories and all sorts. And then the perm, I want the user bit to have the SUID bit set. So the S is the SUID bit. At the moment, I'm not running as root. I will get a lot of permission denied errors every time we try search somewhere we can't. So I'm just going to redirect all those errors to dev null, so we do not see them on our screen. Our response will purely be the SUID binaries we're looking for. Yeah. So we can start from the top. There's a lot of these snap core ones. I never know why these all turn up here. I've got no idea, but I just look at the ones which are in like user sbin or user bin. What you may want to do, you may want to reference GTFO bins. So this is a great website which basically has a list of Linux binaries which are commonly exploited, or they're like lull bins which can be exploited for privilege escalation. In this case, we're only looking for SUID binaries, but we can see all of these here are SUID binaries. What you may want to do, if you're not unsure if a binary is SUID, let's take, for example, pkexec. We can search on here pkexec, and we can see there is a privilege escalation capability with pkexec, but it's only capability if we have the sudo. We can run it as root a sudo. In this case, we've got pkexec being a SUID binary, not sudo. So you can go through and check these. I know from experience none of these are. When I did this originally, one really stood out to me, and that's this sysinfo binary. I had never seen this before. I've seen systeminfo, which I'll just show you on my Kali machine. I don't have it, never mind. Okay, maybe it's a Windows binary. That would be embarrassing if it is. Let me just check on my Windows machine. Yeah, it's a Windows binary. Okay, that's where I recognised it from. But we've got this sysinfo SUID binary, and I hadn't seen this before. So let's just let's tack LA this. We can see, look, it's in the users group, which is strange as well. And if we just go ID, we can see we're also in this users group. So we have read access over it, we have execute access, and we also have the SUID bit. So we will, when we execute this, we will execute it under the permissions of root, and in this case, we'll run it under the permissions of the owner, which in this case is root. Let's just run this, right? What could go wrong? Bin sysinfo, and then we get all this information here about hardware information and disk stuff. I'd never seen this output before, and I was wondering, is this like an actual, like a native Linux binary, or is this like a custom executable which has been written by the creators of this challenge? A nice little trick which sometimes works. It works a lot of the time. Is to get the hash of this. So we'll do md5 sum bin sysinfo. What's happening here? md5 sum bin sysinfo. And what I like to do is go on virus total and then just see if it's been scanned before, or if there's if it's been scanned before. Typically, if it's been scanned before and it's been scanned many times before, it's like a native binary. Somebody else scanned it, it exists. I'm not looking on virus total to see if it's malicious. That's not what I'm doing. I'm just looking to see if it's like it's out there in the world and people have been like scanning it. If you picked any other like binary, just for example, if I just did like md5 sum bin bash, just for example, just so I can prove the point. If I scan this, we would get, file is distributed by Linux. In this case, it isn't. So this gave me a suspicion this was a custom binary written for this challenge and it was meant to be exploited. Let's just have a look at the file type, right? We go bin sysinfo sysinfo to have a look at the file type. We can see it is it's like a binary. It's not like a a bash script or something which is executing is like an actual binary, and it's obviously got the set UID bit set. What I want to do is have a look what this is actually doing under the hood. We can see when we execute it, and I'll execute it again, it gives us CPU info here, it gives us some hardware info, and some of these outputs may be familiar. So especially this one, I've seen this before, I can't remember off the top of my head. Some of these outputs, disk info, they look similar to me. I've seen them before, so I had a suspicion that there may be some commands, normal Linux commands, being run under the hood of this. So you may want to analyse this binary. There's a few ways you could do this. You could move this over to your HackTheBox, and you could perhaps do ltrace on it and trace the library calls and the system calls which are being made. Or you can maybe just run strings on it, take the easy way out, bin sysinfo. Maybe this will give us an idea of what's being run. We can see some of the function imports here. And then if you go up here, we can see more strings on the hardware info, CPU info, and mem usage. We can see the commands, the binaries which are actually being used. In this case, it's using cat, it's using fdisk, it's using lshw, which I'm not too familiar what this is. Can I go man on this? No, it's not there, never mind. Obviously fdisk, I've seen this before, same as cat, it's just showing the contents of a file. With these binaries here, they're not specifying the full binary path, right? They're just using them. So I could say which cat, for example, or which fdisk, and it will tell me the full file path. In this case, it's not. It's just referencing the name of the binary, and then how. Have I? Can I just bin bash this real quick? Can I get this bin bash? Okay, I'm going to have to kill this shell, and then I'm going to do this again. I'll quickly get back to where I was. I'm guessing, yeah, not found. I'm going to upload this again, and then I'm going to send this again, and then I should have the web shell there. Nice. I'm going to quickly python 3 taxi import pty.spawn bin bash. Yeah, this shell seemed a little bit unreliable. Something broke. I don't know what I did. And then I'm going to export term equals xterm. There we go. I'm back to where I was. When I strings this bin sysinfo, oh yep, I need to change user to the thesis. There we go. And then I'm just going to cat creds, get this password here, and I'll paste this in. Now I'm with the thesis user. Nice. We're back where we were. We can strings on bin sysinfo, and like I mentioned, let's take fdisk for example, or cat for example. It's referencing the name of the binary, but it's not referencing the full path. So we can exploit this. When I in Linux, when I reference, let's say, just cat without specifying the full file path, I'll do this on my Cali machine. So we can see that's the full file path, user bin cat. When I just reference cat, what it does is it goes through the path environment variable and then checks these directories one by one to see if the cat binary exists. So let's actually just let's do this again. Let's echo path just so we don't get that filled up path, and I'm also going to say which cat. So what it does, it knows it's in, when I reference cat like this without referencing the full file path, it goes through this path environment variable and then it checks the directories one by one. So it will go to this directory to begin with, it will go to user local sbin, and it will say, is cat in here? No, it's not. It'll go to this one, is cat in here? No, it's not. And then it will go through one by one through these different directories in the path environment variable, eventually until it gets to the user bin path, and in this case cat will exist in there, so it will say yes, I will execute this. So that's how Linux when we don't reference the full file path of the binary, it checks whether it's on the system. In this case, we don't have the full file path supplied, so we can sort of exploit this. What I can do is I can go to a temp directory. Let's just go to temp. And then I can do the same thing of echoing path here. So we can see it's going to go start on this one, and then it's going to check and check. I can add my own directory to the path environment variable, and this means it will check that directory first. In this case, we know it's going to run the cat command at some point. We know that's the case. So what I can do is I can do something like this. I can say I want to echo bin bash into cat, because I know cat is going to be run. I'm also going to make this executable, so when it executes cat, it's actually just going to execute bin bash. And then at the moment, if we look at our path environment variable, and we also go which cat, it's going to check the bin directory, so it's going to go through all of these eventually until it gets to this bin directory, and then it will find it. What I can do is I can add my own directory to this. So let's just do this real quick, and then I'm going to export. I'm just going to echo path now. Echo path. We can see I've added the temp directory to the top of the path environment variable, and if we go ls in the temp directory, we've got that cat file there. And if you cat the cat file, actually no, I'm going to have to do, that won't work in this case. I'm going to go bin cat on cat. We can see it just runs bin bash, so it's going to pop a shell. But the thing is, when we run this sysinfo binary, it's going to use the cat command, which will get a shell, but the sysinfo binary is a SUID binary owned by root, so we're going to get a shell as root. That is what should happen. I did have an issue with this when I originally did this, and I couldn't see the output of any of my commands, but we'll see if that does it now. Let's just run this again, because we know it's bin sysinfo. What happens? It runs, and now we can see we're running as root. If I run id, I can't get any commands. If I go who am I can't get any response to any command. I can go around directories. I can also go in the root directory, but for some reason I cannot I cannot see the output of my command. For some reason it's messing it up. So there's two things I did at this point. I know the root flag is going to be in the root directory, so what I just did is I copied root.txt, and I moved this to temp root.txt. I'm then just going to give that permissions that anyone could read it in temp root.txt. The second thing I'm going to do, just so, that will allow me to get the flag, but I do sort of want to get a nice shell where I can see it. What I'm going to do is I'm going to go back to this GTFO bins, and then I'm going to, as I've got root, I can make myself a privilege escalation vector. So I'm going to go to find, because I know this is a pseudo capability. And then what I can do is I can set, I can make the find binary SUID, and then I can run this exploit and get another shell like this. So what I'm going to do is I'm going to go chmod u plus s. So I'm going to set the SUID bit on the find binary, which, let me just find out where this is, which find, it's not going to output there, okay. I may just be able to do it like this, u plus s on find, okay, chmod u plus s on user bin find, that worked. So at the moment, like I said, I can't get any output to any command, which is really annoying because I can't see what's going on. So I'm going to kill this shell, and then I'm going to go generate a new one, get back to where I was originally. So I'll upload it again. I'm going to get the shell, back to where I was, Python 3, taxi import pty.spawn, bin, bash, like so. I'm going to export term equals xterm. I'm just going to show you now, if I go to the temp directory, the root flag is there and I've got access over it. However, if I go ls tac la on user bin find now, we can see it's got the SUID bit set. So what I can do is I can use this proof of concept here for privilege escalation, this vector. I can run this, I can say ID, and I've now got my effective user ID set to root, so I can go to root anyway, and if I wanted to, I could cat the root flag. There we go, it works. We've privileged escalated to root. As I did mess around in the temp directory and make the root flag accessible to all users, I am going to remove this so this doesn't work. I'm also going to remove cat. But we have solved the challenge. I don't know when we did that path hijacking with the SUID sysinfo binary, I don't know why I couldn't see the output. If anyone wants to put in the comments the explanation of that, I'd really appreciate that. But we did find a way to bypass it and get like a sort of fully functional shell anyway. So this is this challenge done. I hope you enjoyed, and I'll see you on the next one. Cheers.